Good morning, students. I would invite Arun sir to start the session.
Thank you, ma'am. Good morning,
Thank
everyone.
you.
Good morning, sir.
Good morning.
Good morning, sir.
Sorry I'm late. All right. So we'll start with a new chapter, motion in a plane, or motion in two dimensions. All right. So let us understand few things, certain things from perspective of second two dimensions. All right. In this motion in a plane, we are first going to discuss accelerated motion under gravity or constant acceleration. That means when a particle is projected under gravity or particle is projected in a region where there is a constant acceleration. All right. Then we'll go for variable acceleration again, in which we have got different time kinds of motion in a plane. All right. Some will get a spiral, we'll get circular motion, spiral motion, and so on. But first will be parabolic motion. All right. So we know what a parabola is. You have seen what a parabola is yesterday.
Yes, sir.
Just a second. Okay. Okay. So what are we going to study in this case is when a particle is projected, I've got, let's say I've got some particle. If I project it in this under this gravity, all right, how did it move under gravity? All right, that's what we're going to study. A particle projected, a bomb projected, some object projected from the airplane, or some tank firing a bomb from the tank from ground. Where does it land? How does it land? After how much time does it land? How much does it cover? How much area does it cover? All right, all such questions we'll be dealing with. So we'll do the analysis of the motion in which there is a constant acceleration. In this case, there is constant acceleration which is under gravity g, and a particle is projected like this. So the particle goes in a certain path, which will derive what kind of path it is. But we'll start with motion in which I project a particle horizontally under gravity. I'll write bigger, sorry, under gravity. All right. So we'll have some path like this. So what kind of path it is, we'll derive. But we know that the path is going to be like this because we see everyday life, right? If I throw a particle like this, it doesn't go straight. It does go downward, right? So we'll start with this today. We'll come to this, then we'll go for an inclined plane. What happens and how do I deal with problems on an inclined plane? All right, so these three scenarios, and I'm writing a G over here because I'm doing whole of the scenario, whole of the analysis under gravity G. But this also works for some acceleration A, which I write or Gx, G effective. All right, I'm writing Gx is G effective. Why I'm saying G effective, you'll understand after a while. But and that is very important. It could be anything. Let's say if I do it on moon, it is G effective is equal to G by 6. If I do it on Earth, G effective is G. If I do it on some other planet, G effective will be something else. If I do it in a lift moving with certain acceleration, then G effective is something else. If the lift is moving down, G effective is something else. So motion under gravity or motion under constant acceleration is what we are studying. Acceleration is always constant. And I throw a particle, and how does the particle go? Is what we are studying. All right. So I hope this is clear now. What we are going to study is clear. We are going to study motion, the detailed analysis of a motion of a particle thrown in a region where there is constant acceleration. So constant acceleration is being acted on the particle. See, acceleration is constant throughout. Why do I say constant throughout? No matter where the particle is, my g is downward itself. No matter where the particle is, my g is downward. No matter where the particle is, my g is downward. Even if the particle is here, my g is downward, which is acceleration due to gravity, which is constant throughout. All right. It is not that g is changing with time or with point. All right. G is constant throughout, and that motion we are studying. All right. And another thing, is it clear what we're going to study?
Yes, sir.
Yes.
Yes,
Okay.
sir.
Okay. Under constant acceleration, which gx. Gx could be g on Earth. Gx is g by 6 on Moon. Gx is something in a lift. Gx is something when the lift is going up. Gx is something when the lift is going down. But Gx is constant throughout motion. And that is what we are studying. Motion under gravity or motion under constant acceleration is what we are studying. We will start with motion under gravity, in which case the particle is projected horizontally. All right. To study that, I'll mention a point before that, which is if I have some trajectory in xy plane, some trajectory like this, some random trajectory, some random trajectory like this, then motion along this trajectory can be split into two motions: motion along x-axis, motion along y-axis. That means if a particle is moving along x-axis with certain velocity and acceleration, and particle is moving with another particle which is moving along y-axis with certain velocity and acceleration, intersection of these two is what I get this trajectory. All right. So I can split this motion of the trajectory on in terms of two independent motions, x and y. Motion along x-axis, motion along y-axis. All right. For instance, if I have got a straight line, which is b is equal to y is equal to x. All right. Now, motion along this line can be understood in terms of as a superposition. All right. Superposition is nothing but I combine two motions. I superpose two motions which are independent of each other, perpendicular to each other and independent of each other. When I superpose is combining these two to get the resultant motion. For instance, if a particle is moving along V0 with V0 along this axis, y is equal to x. So this can be combined as, if this is 45, because it's y is equal to x, slope is 1, which is tan inverse 1 is 45. So angle of inclination is 45. So what is the horizontal component of this velocity? V0 cos 45, which is V0 by root 2. What is the vertical component of this velocity? V0 sin 45, which is V0 by root 2. Do you want me to revise components?
Yeah, sir.
All right. I'll quickly revise components. Let's have got a vector. Vector V naught. All right. Vector V bar, whose magnitude is V naught. All right. Now, I've got some line like this. All right. It could be horizontal or it could be somewhere like this. And this angle is theta. Now, component of this V along this line is nothing but shadow of this V along this line. I always talk of shadow. Whenever I say talk of component, it's nothing but shadow. What kind of shadow? That means where is my light coming from? If I say shadow, there should be some light source from where the light is shining. So light is shining in this way, perpendicular to the line, and I get a shadow of this vector on this one like this. And this is nothing but the component of V on this line. If I've got a line like this, then I'll shine light perpendicular to the line, and component will be shadow of this vector on this line. If this is psi, so that will be, in this case, is V naught cos theta. In this case, it is V naught cos psi. Is it clear? So shadow is nothing but cos component, or cos component is nothing but the shadow of the vector along the line when the light is shining perpendicular to the line. All right. So whenever I talk of component, think of a shadow. Think in terms of shadow. Then how do I get the length of the shadow? Length of the shadow is nothing but, let's say, that's question mark. So that question mark by V naught in this right angle triangle is cos psi. So question mark is equal to V naught cos psi. So length of the shadow is nothing but V naught cos of psi. That's why it's called a cos component. Cos of the angle between the line and the vector. All right. If the line is perpendicular to this vector, then what kind of shadow you get? What is the shadow when the line is perpendicular to the vector? You get a point, right? Length of the shadow will be 0. If I
Zero,
shine
sir.
light, right, 0. Because if I shine light like this, I'll get shadow to be a point, length of which is 0. So shadow is a point, that means length is 0. I'll substitute cos of what angle? V naught cos, what is the angle?
90.
90.
Yes.
90, cos 90. That's why I get cos 90 as 0. All right. So shadow or component is nothing but shadow when a light is shining perpendicular to the line. Length of the shadow is given by V naught cos of angle between the line and the vector. All right. Is it clear? Now, let's say I've got a line like this. And the vector is like this. This is V naught. This is theta. So what is this? What is the shadow of this along this line? V naught cos theta. Agreed? Now I have got another line which is perpendicular, which is like this. Sorry. Like this. And this angle is psi. What is the component of V naught along this line? Students, what is the component of V naught along this line? It is V naught cos psi. V naught into angle between them, cos of angle between them. So this would be V naught. This length would be V naught cos psi naught. Right? Is it okay?
Yes, sir.
Now let us say I've got V naught is this one. This is 60 degrees. I've got another line. Or let's say this is 45 degrees. I've got another line which is making another 60 degrees with this line. So what is the component of V naught along this line? It is V naught cos 45. What is the component of V naught along this line? V naught cos of this angle. See, component antenne cos. All right. Component antenne cos. The moment I say component, you should think of cos of the angle between them. So what is the cos of angle between them? Cos of 60 minus 45, which is 15 degrees. So V naught cos 15 is my angle, sorry, projection or component of V naught along this line, along line A, along line B. So along line A, it is V naught cos 45. Along line B, it is V naught cos of angle between the line and the vector. Angle between the line and the vector is 60 minus 45. Why is it 60 minus 45? 60 is the angle between two lines, A and B. 45 is the angle between vector and the line A. So this remaining angle will be 60 minus 45, which is 15. V naught cos 15 is a component along line B. Agreed?
Yeah, sir.
Yes, sir.
Yes, sir.
Okay. Now, instead of having an angle of 60 degrees, what I do, I have two perpendicular lines. So what is the component of this one along this line A?
60 degree.
No, this theta and psi.
Bad day.
Sorry?
180 degree.
No. I'm asking you what is the component of V naught along line A?
Cos theta.
Cos theta. So V naught cos theta. V naught cos of angle between them. So this would be V naught cos theta. Right? And what is the component of this V naught along this line?
Cos
Sin of
theta.
V
V naught
cos
cos psi.
theta.
No, this is psi. This is psi. This is theta. This is psi. Psi is nothing but PSI. Read as psi. Psi laga చదువుతాము psi. SIGH అనుకోండి.
Cos
Psi. So V naught cos psi.
Yes, sir. We not cos.
But I said these two are perpendicular. So what is psi?
V not.
90 minus
90
theta. So this would be V naught cos of 90 minus theta. What is cos 90 minus theta?
Sin.
sin.
Sin theta.
sin theta.
Sin theta. So then I get vertical component as V naught sin theta. You understood why am I getting sin theta here, cos theta here? When
Yes.
so ఎప్పుడైనా component of this along horizontal axis అంటే cos theta అంటే vertical axis is sin theta. But how am I getting that sin theta? It is cos of the angle between these two. But this angle is 90 minus theta. So that's why it is sin theta. If this angle were not 90, let's say if this angle were 60, like this. So what will the angle be if this is theta and psi? So what is the component now? V naught cos theta here, V naught cos psi here. Psi is nothing but 60 minus theta. So V naught cos 60 minus theta ఇక్కడ ఉంటుంది. V naught cos theta ఇక్కడ ఉంటుంది. Right? But here because it is 90, that became sin theta. So component అంటేనే cos. All right. Now let us say if I give you, instead of giving theta with the horizontal, I give you this as theta. Now tell me what is the vertical component?
Sin theta.
No. Look at the diagram and tell me. V naught cos of angle between them. E component. Now component along line B కావాలి.
Cos
So
theta.
right. V naught cos theta. Now what is the component over here?
V
V
not
naught cos of
theta.
right. V naught cos of 90 minus theta, which is V naught sin theta. So vertical component
Yes,
is sin
sir.
theta ఉండదు. Alright. Usually students will remember vertical component sin theta, horizontal component cos theta. No. Component అంటే cos theta. That is theta is angle between the line and the vector. In this case, this is theta. So V naught cos theta ఇదే అయిపోతుంది. And this becomes V naught cos of 90 minus theta, which is sin theta. So measure the angle between the line and the vector always. Component అంటేనే measure the angle between the line and the vector. Alright.
Yes,
don't
sir.
So don't remember in terms of sin theta and cos theta, but component is nothing but cos theta, where theta is the angle between the line and the vector. Alright. So that's about components. Now let's come back to that motion along y is equal to x. I've got line y is equal to x. A particle is
What
moving with
is
velocity.
Booster?
Sorry?
What is Booster?
What is?
Motion.
Motion is nothing but when you have a change in position is motion. That results in motion. Let's say I've got a origin here. All right, ఒక వన్ డిమెన్షన్ లో వెళ్తుంది. We talked about motion in one dimension also. So ఇక్కడ నుంచి పార్టికల్ పొజిషన్ A నుంచి పొజిషన్ B కి వెళ్ళింది. So there is a change in position. Change in position results in
Motion. Thank you, sir.
motion. Motion is nothing but change in position.
Okay.
All right. Now that has different aspects. Displacement, velocity, acceleration, jerk, bounce, అవన్నీ ఉంటాయి. But motion is nothing but if there is a change in position, there is motion. Now, two dimension law, if this is origin, particle is here initially, particle goes here afterwards, then there is a change in position like this. So that's motion of the particle. So we are studying motion in a plane, a plane law, under constant acceleration. All right, we are studying a very specific kind of motion which has got wide applications. Motion that is change in position in a plane. I'm not studying in three-dimensional space. I'm studying only in a plane under constant acceleration, which is gx. Gx is equal to g on Earth, g by 6 on Moon, something while the lift is going up, something while the lift is coming down, something like that. All right, something when the car is going towards right, something when the car is going towards left. Okay, left and right. I told you the opposite. All right. So motion along this line can be understood as a superposition. Superposition is a technical term in which what it means is I superpose or I combine these two motions one over the other. That means if this is moving velocity v naught, this angle is 45 because its equation is y is equal to x, I told you. This is an xy plane, two-dimensional plane, motion in a plane. So its component, what is the velocity component along x-axis? V naught cos 45, which is v naught by root 2. What is the component along this axis? V naught cos this angle, which is also 45. So V naught root by root 2.
Yes, sir.
Now, if I draw a vertical, let's say this particle is having a stick, infinite long stick. All right. This particle is holding this person over here on the particle. Sorry. Yes, please. Yes, please. Okay. All right. Now, I've got, let's say this particle is holding a long stick like this, long rod. And he's moving with velocity v naught by root 2 like this. He's holding a long rod and he's moving with v naught by root 2 like this. And this person, vertical axis, he's holding a horizontal rod and moving with constant velocity v naught by root 2 upward. He's holding a rod horizontally and moving upward. All right. Now, intersection of these two lines is what results in y is equal to x. Understand this point clearly. I've got v naught by root 2 this way, v naught by root 2 this way. So, distance traveled after some time would be x is equal to v naught by root 2 into t. Agreed? Ut plus half a t square. A is 0, so x is equal to ut. Similarly, y is equal to v naught by root 2 into t. Vertical distance. Now, I want to eliminate t. Y is equal to v naught by root 2 into t. X is equal to v naught by root 2 into t. If I want to eliminate t, I'll divide these two. T gets cancelled out. V naught by root 2 gets cancelled out. I'll get y is equal to x. So I got the trajectory of the particle as a superposition of the two motions. By eliminating t, I got equation of the trajectory of the particle. But how is this particle moving? Horizontally, we're holding this rod. This particle is moving vertically, holding this rod. Intersection of these two rods is a point along which this సూపర్‌పొజిషన్ ఆఫ్ దీస్ 2 మోషన్స్ ఇస్ మూవింగ్. ఈ పాయింట్ ఎలా మూవ్ అవుతుంది నేను స్టడీ చేస్తున్నాను. ఇది 1 డైమెన్షన్, ఇది 1 డైమెన్షన్. సో మోషన్ అలాంగ్ దీస్ 2 ఇండిపెండెంట్ 1 డైమెన్షన్స్, సూపర్‌పొజిషన్ ఆఫ్ దీస్ 2 ఇస్ దిస్ పాయింట్. ఈ పాయింట్ ఎలా మూవ్ అవుతుంది నేను కనుక్కోవాలంటే ఐల్ రైట్ హారిజాంటల్ మోషన్ యాస్ ఈక్వేషన్ రాస్తాను. వర్టికల్ మోషన్ ఈక్వేషన్ రాస్తాను. I'll eliminate t. I'll get y is equal to x or some equation, which is the equation of the trajectory of the particle. All right. You understood how I got the trajectory of the particle? I got trajectory from 2 independent motions. ఈ motion ని t terms లో రాశాను. ఈ motion ని t terms లో రాశాను. I eliminated t. t ఎలా eliminate చేశాను? I'll find t from this one. I substitute it here. Or I divide these two. T cancel అయిపోతుంది. V naught by root 2 cancel అయిపోతుంది. So y is equal to x is the equation of trajectory of the particle which is moving with horizontal motion as v by root 2, horizontal velocity as v by root 2, vertical velocity as v by root 2. All right.
Sir, why
Equation-
you have written
Yeah, why I have written
T into T?
into t. See, velocity is v naught by root 2. What is the displacement? S is equal to ut plus half at square kada?
Yes, sir.
We are going to use this equation only, and v is equal to u plus at. And v square minus u square is 2as rarely. Only these two equations we'll be using throughout the chapter, but tippy use chestam ante. All right, we'll be using just these 3 equations. We'll not be going for variable acceleration now. There is only one case of variable acceleration in motion in a plane that we'll in a parabola that we'll talk about later. Parabolic motion, circular motion, spiral motion. 3 motions ఉన్నాయి plane లో. Motion in a plane has got 3 segments. Motion is parabolic under constant 1, circular motion, then spiral motion. ఈ 3 motions మనం ఎక్స్ప్లోర్ చేస్తాము. But we are first doing parabolic motion. Parabolic నేను పేరు ఇచ్చేసాను, but I didn't derive parabolic. Parabola ని derive చేయలేదు. Alright, just చెప్తున్నాను. I'll derive why it is called a parabola. But first section of the motion is under constant acceleration, which is gx. Gx is equal to g on earth. Gx is equal to g by 6 on moon. Gx is something in a lift. Gx is something in a car. But it is gx. Ultimately, it is gx under which I'm studying the motion. When a particle is, ఒక particle ని ఇసిరేస్తే, ఒక particle, if I project a particle under this gx, how does the particle move is what I'm studying throughout this first segment of the motion in a plane. So 3 segments లో ఏమున్నాయి? ఒకటి అండర్ కాన్స్టెంట్ యాక్సలరేషన్ gx, ఒకటి సర్క్యులర్ మోషన్, ఒకటి స్పైరల్ మోషన్. ఆల్రైట్. సో ఈ gx ది this gx motion will turn out to be a parabola. That's why I'm calling parabolic motion, circular motion, spiral motion. I didn't derive it. We'll derive it. We have a lot of time. We'll derive it. కానీ ఈ మోషన్ ఎలా ట్రెజెక్టరీ ఎలా తెచ్చుకుంటాను? సింప్లెస్ట్ కేస్ ఇది. సింప్లెస్ట్ కేసులో ఏమవుతుంది? horizontal motion is moving with velocity, constant velocity v naught by root 2. Vertical is moving with constant velocity v naught by root 2. He is holding an infinite rod. He is holding an infinite rod horizontal. He is holding an infinite rod vertical rod. S is equal to ut plus half t square యూస్ చేస్తే a is 0. I'll get s is equal to ut. అందుకే v naught by root 2 into t వచ్చింది. ఇక్కడ కూడా v naught by root 2 into t వచ్చింది. ఇప్పుడు నాకు పారామెట్రిక్ ఫార్మ్ ఆఫ్ ది హారిజాంటల్ అండ్ వర్టికల్ మోషన్ వచ్చింది. ఇప్పుడు పారామీటర్ ఏంటి? టైం. If I eliminate that time, I'll get an equation between y and x. Right? I'll get the equation between y and x. Y is equal to v naught by root 2 into t. X is equal to v naught by root 2 into t. I have to eliminate t. So what I'll do, either I can divide or I'll take t from here. T is equal to root 2x by v naught. I substitute this t here in this equation, y equation lo. Y is equal to v naught by root 2 into root 2x by v naught. V naught gets cancelled, root 2 gets cancelled. I'll get y is equal to x. Identi, this is a relation between y and x. So this is the locus of the particle. Locus వచ్చింది నాకు. What is locus? You'll get an equation.
Equation.
Yes, sir.
Right, I got an equation. Now this is the equation along which the particle is moving. So equation draw చేస్తే ఎలా ఉంటుంది? Y is equal to x ఉంటుంది. So my particle is moving along this straight line. సరేనా?
Yeah, sir.
Yes, sir.
All right. Now, so I repeat, just for a minute, I'll repeat. This motion in a plane, I'm splitting this motion into three segments. Motion under parabolic motion, circular motion, spiral motion. Motion under constant acceleration is what we are studying. Under constant acceleration, which is gx or effective g, gx, effective g or constant acceleration, turns out to be parabola. That's why I'm calling it parabolic motion, circular motion, spiral motion. Ikkada acceleration ela untundi, we'll talk about later. Variable acceleration. But ikkada constant acceleration. That means acceleration is always downward or always in certain angle or upward, downward, upward, ఏదో ఉండొచ్చు. But certain angle only the constant ఉంటుంది. That turns out to be parabola. Right? That's why I'm calling it parabolic motion, circular motion, and spiral motion. Okay.
Sir,
Yes.
I think we need to be fill the attendance form.
Okay, okay. Take a minute. Till then, I'll just draw the diagram.
Sir, is it 40 or 90, sir? Degrees.
Between
Angle
what?
between.
Angle between what and what?
No, sir, is it angle is 90 or 40?
This is theta naught. Sorry. This angle is theta naught.
Okay, sir.
Right? Angle between the horizontal, let's say x-axis, and this is y-axis, is theta naught. Now, so this will go in some path, right? I don't know what kind of path. From our common sense, because I'm writing a g, from common sense, I can say it goes in a parabola like this. Right? It goes in a parabola like this. Some path like this. That path I don't know. Some path which is downward like this, which has a cup downward. ఈ పాత్ వెళ్తుందని మనకు తెలుసు బట్ ఈ పాత్ ని ఏమంటారు మనకు తెలియదు ఇంకా తెలియదు మనకి unless I get the equation of the path I can't say what kind of path it is. See, it looks like one cup downward ఉంది. That could be hyperbola, that could be parabola, that could be one segment of the hyperbola ఉండొచ్చు, or it could be parabola ఉండొచ్చు, or it could be part of a circle ఉండొచ్చు. I don't know, but I know that this is somewhere some like downward curve. అది ఏ ఈక్వేషన్ ఎలా కనుక్కుంటాను? I'll find the equation of it, then I'll say what kind of equation it is. By looking at the equation, I'll say what kind of curve it is. Sorry, by looking at the equation, I'll say what kind of curve it is. Right now, I don't know what kind of curve it is, but common sense says it's a downward curve like this. All right. Okay. Now, look at this. Horizontal component ఏంటి ఇప్పుడు? V naught cos theta of the velocity. Right? What is the horizontal component of G?
Downward.
G is downward, right? This is horizontal. G is downward. దీని కాంపోనెంట్ ఎంత ఉంటుంది horizontal లో? A
Is it
vector is
perpendicular?
perpendicular. Yeah, it's perpendicular. G is downward and this line is horizontal.
45 degrees.
No, I'm not talking about the angle. Angle is given 90 degrees. I'm asking you what is the component of this vector along this line?
Cos 90.
Sorry?
Cos 90.
Yeah, 0. Cos 90. Shadow is point. So length of the shadow is 0, which is G cos 90, 0. So acceleration component of the acceleration due to gravity on the horizontal axis is 0. So horizontal point, which is holding an infinite rod like this, is going with a constant velocity, but no zero acceleration. Z plus half at square raste, V naught t plus half at square raste is 0 into t square vastundi. So this is 0. So it's going with constant velocity along the horizontal. So this vertical rod is going with constant velocity along the horizontal. Now, how about the vertical motion? Vertical component ఏముంది? V naught sin theta.
Yes, sir.
And G is acting downward. So this is a retarded motion. I told you these are two independent motions. This is straight line motion. This is straight line motion. E straight line motion constant velocity on the E straight line motion constant acceleration on the. So it is projected with V naught upward. G is downward. So particle will retard eventually. Retard I see when I'm talking about vertical, I'll think of only vertical. This person is holding a horizontal rod like this. So this horizontal rod is going up, stopping, and then coming back. Right? But this vertical rod is just going with constant velocity like this. Intersection of these two is my locus. Something like this. Why did I draw like this? Because this line goes up, stops, comes down. Whereas this line keeps going. So that's why I've got a downward curve like this. This point goes up, stops, comes down. So this line, horizontal line, is going up like this. It's stopping here, again coming down. Right? Is it okay? Is the visualization okay?
Yes, sir.
Yeah, Vignesh, now it's reaching. Your voice is reaching me now.
Yeah, sir.
Yeah, okay. All right. Now, thanks for interacting. Good. So, ఏదో path వస్తుంది ఇలా కామన్ సెన్స్ చెప్తుంది దట్ ఈస్ డౌన్వర్డ్ పాత్ అని బట్ దట్ ఐ కెనాట్ టెల్ యూ వాట్ కైండ్ ఆఫ్ కర్వ్ ఇట్ ఇస్ అన్లెస్ ఐ నో ద ఈక్వేషన్ ఆఫ్ ద కర్వ్. ఇంతకు ముందు y is equal to x వచ్చింది దెన్ ఐ కుడ్ సే ఇట్ స్ట్రైట్ లైన్. ఇప్పుడు కూడా ఈక్వేషన్ రావాలి
Yes.
నాకు. సో unless I get the equation, I cannot say which curve. So let us get the equation now. Okay. So vertical motion ఎలా ఉంటుంది? Y is equal to V naught sin theta t minus half g t square. అంతేనా?
Yes, sir.
Yes.
What is horizontal motion? V naught cos theta naught into t. Now I have to eliminate t. Now I cannot divide this and eliminate t, cancel చేయలేను. సో ఏం చేస్తాను? t ఇక్కడ నుంచి తీసుకొని ఇక్కడ సబ్స్టిట్యూట్ చేస్తా. What is t from here? X by V naught cos theta.
Yes,
Right?
sir.
So I'll substitute that over here. So y is equal to V naught sin theta
Sin theta into
into
x by v naught cos theta into t.
yes, good.
minus
t
one-
లేదు
one
ఇప్పుడు
by
t లేదు ఇప్పుడు t ఏ సబ్స్టిట్యూట్ చేశాను.
yes, sir. 1/2 g x by v naught cos 90 by
No 90,
t
not 90, cos theta.
sir cos 90 అన్న.
Cos 90 ఎందుకు వస్తుంది?
Okay,
Cos
sir.
90
theta theta. Okay, right,
రైట్
sir.
cos theta కదా చూడండి t is equal to x by V naught cos theta. t సబ్స్టిట్యూట్ చేస్తాను నేను.
And
Alright.
sin 90
సారీ.
అక్కడ sin 90 ఉంది కదా సార్ దానివల్ల కన్ఫ్యూజ్ అయిపోయారు.
Okay, that's okay. Now look at this. I'll further simplify this. V naught is getting cancelled out here. It is becoming sin theta by cos theta is tan theta. So I'll have y is equal to x or tan theta into x minus gx square by 2 v naught square cos square theta. Is it okay?
Yes, sir.
Okay. Would g by 2 v naught cos square theta into x square. All right. ఇప్పుడు ఈ ఈక్వేషన్ చూడండి. Did you understand this? How I got it? I'll repeat the thought process. Thought process ఏముంది? I've got a horizontal motion which is independent of vertical motion. Horizontal motion is that rod is going with constant velocity. This rod is going with initial velocity v naught sin theta, but it's retarding. G is కింద ఉంది. Retarding will go stop and then come back. Retard అవుతుంది, జీరో అయిపోతుంది, మరి స్పీడ్ ఇంక్రీజ్ అవుతుంది. So this is how the vertical motion is. ఆ రెండింటిని ఈక్వేషన్ రాశాను, పొజిషన్ ఈక్వేషన్ రాశాను. x is equal to v naught cos theta t, y is equal to v naught sin theta t minus half gt square, ut plus half at square. మైనస్ ఎందుకు వచ్చింది? బికాస్ v naught అండ్ g are opposite directions. v naught upward ఉంది, v naught sin theta upward ఉంది, g downward ఉంది. All right. So now look at this. I substitute t is equal to x naught by x by v naught cos theta. ఆ t ని ఇక్కడ సబ్స్టిట్యూట్ చేస్తే I'll eliminate t, I'll get an equation between y and x. Y and x between మధ్యలో ఈక్వేషన్ వచ్చింది. This equation can be written thought as tan theta as a, this as b. I have got y is equal to ax minus bx square.
Yes, sir.
All right. Now, yesterday we have seen conic equation.
Sir, is the equation is hyperbola?
Yeah, let's see. That's a good question. Let's see. So bx square minus ax plus y equal to 0. So ఇక్కడ a bx square minus ax plus y equal to 0. So నిన్న ఈక్వేషన్ తో కంపేర్ చేస్తే ax square plus bxy plus cy square plus dx plus ey plus f equal to 0. Right? ఇక్కడ b term లేదు. See, if I compare this to, this is the second degree equation with c0 ఉంది, b0 ఉంది, f0 ఉంది. Are you convinced? It's a second degree equation. That means it's a conic. It is definitely a conic. అది conic section వచ్చింది నాకు. Are you all convinced?
Yes, sir.
Yeah, Omkar, your voice is not clear. You said something?
I not understand, sir, this.
అంటే ఎక్కడి నుంచి అర్థం కాలేదు?
Sir, this equation, x.
ఓకే. ఈ ఈక్వేషనా?
Yes, sir.
ఈ ఈక్వేషన్ ఎలా రాశాను? tan ని a పెట్టాను, g by 2 v naught square cos square theta ఇది కాంప్లెక్స్ ఫామ్ ని b పెట్టాను. కాన్స్టెంట్ కదా, ఇది కాన్స్టెంట్. theta is constant, v naught is constant, g is constant, theta is constant, tan theta is constant. So this is a constant into x, a into x. This is a constant into x. So a naught x minus b naught square, b naught x square, sorry. ఈ ఈక్వేషన్ కంపేర్ చేస్తే నిన్నటి ఈక్వేషన్ తో I've got ax square plus bxy plus cy square plus dx plus ey plus f equal to 0. కంపేర్ చేస్తే both are second degree equations. This is also second degree equation, right, in x and y. So this has to be a conic. ఎందుకంటే this form of equation is a conic. Now for that to be a conic, after that being a conic, I'll see whether it is xy term ఉందా లేదా. xy term లేదు. So that means my conic is going to be with axis horizontal or vertical. It's not tilted conic. ఇది tilted conic కాదు.
Yes, sir.
కానీ x term ఉంది, y term ఉంది దీంట్లో. So that's a shifted conic. కానీ c term లేదు.
Okay.
Now c term లేదంటే I've just got a term. So b square minus 4ac రాస్తే b is 0 minus 4 into, what is the A term here? B naught.
Zero,
term
sir.
is zero.
Parabola.
Excellent. That's a parabola. So because
Yes,
discriminant
sir.
is 0, b square minus 4ac is 0, it's a parabola. That means this equation has to be a parabola. I mean, this is an equation. I got second equation with a b square minus 4ac is 0. That means this curve has to be a parabola. హైపర్బోలా కాదు. ఓకే, ఇప్పటివరకు నాకు కన్ఫ్యూజన్ ఉండే, ఇది హైపర్బోలా లాగా కనిపిస్తుంది, పారాబోలా లాగా కనిపిస్తుంది, క్యాటనరీ లాగా కనిపిస్తుంది, సమ్ డౌన్వర్డ్ కర్వ్ ఉండేది. But I wanted an equation to be sure of what kind of curve it is. So I got an equation which fortunately happened to be a second degree equation. That means which is a conic. A conic lo kuda, which kind of conic it turned out to be?
Hyperbola.
Parabola.
Parabola.
Parabola. See, b square minus 4ac is 0. Vignesh,
Yeah, sir.
b square minus 4ac is less than 0 ante circular ellipse. b square minus 4ac equal to 0 ante parabola. b
Parabola.
square minus 4
Hyperbola.
greater than 0 ante hyperbola.
Hyperbola.
Right. So it is turning out to be 0. This is parabola. That means this equation is an equation of parabola. That means if I throw a particle from here
Ex-
like this, that will go along path which is a parabola. So parabola will have axis.
Excuse me, sir.
Yes.
Why have you cut a BCF? That part I didn't understand.
Okay. ఈ ఈక్వేషన్ లో చూడు, ఇక్కడ ఉందా xy టర్మ్ ఉందా ఈక్వేషన్ లో? ఈక్వేషన్ లో xy టర్మ్ ఉందా?
No, sir.
xy టర్మ్ లేదు. y స్క్వేర్ టర్మ్ ఉందా?
Okay. Yes, sir.
లేదు. సో b is equal to 0, c equal to 0. d టర్మ్ ఉంది, e టర్మ్ ఉంది. f is also equal to 0. a టర్మ్ ఉంది. a ఎంత ఉంది? b నాట్ ఉంది. a is b నాట్. d ఎంత ఉంది? కానీ d తో మనకి పని లేదు. My equation is conic is decided by only a, b and c. d
Yes,
and e
sir.
will only say that conic is shifted. b will say that
Yes.
conic is tilted.
Dead or not.
But a, b, c will decide which kind of conic. b square minus 4ac చేస్తే నాకు, if that range is above 0, below 0 or equal to 0, that will decide which kind of conic. So that is, it will turn out to be equal to 0. That is parabola. That means it's going to be a parabola. A parabola is an open-ended curve, downward curve. ఇంకా డౌన్వర్డ్ ఎందుకు అంటున్నాను? Look at this. I've got this quadratic with a b x square coefficient as negative. చూడండి, y is equal to ax రాస్తే y is equal to x into, okay, that will do. But you understood it's a parabola, no?
Yes,
sir.
sir.
I have proved it's a parabola. First, I didn't have an idea. I just had an idea that it's a downward curve. Now I proved it's a parabola. Now I got to know what kind of curve it is. It is for sure a parabola. It is interesting to note that it is a conic section. A conic section law, there is not a tilted conic section. It is only a shifted conic section. And b square minus 4ac తీసుకుంటే, it turned out to be 0.
Equal to
It turned
0.
out to be a parabola. Now let us look at further points of the parabola. Parabola has something called axis of symmetry. All right. Parabola is a line symmetric function. Two kinds of symmetric functions, two kinds of functions ఉంటాయి. Line symmetric functions ఉంటాయి, point symmetric functions ఉంటాయి. Parabola is a line symmetric function. What does it mean? I will have a line passing through this peak point, which is called vertex. It is symmetric with respect to this line. E part is reflection of this line. Okay.
Okay, sir.
Okay. Now let us understand. ఇప్పుడు ఇది కనుక్కుందాము. ఈ లైన్ ఆఫ్ సిమెట్రీ ఎక్కడుంది? మళ్ళీ x యాక్సిస్ కి కట్ ఎక్కడ అవుతుంది? x యాక్సిస్ ఆరిజిన్ నుంచి yes please.
Is it imaginary or real, sir?
What is imaginary or real? What is imaginary or real?
That vertex point to lines.
See, line of symmetry, vertex point, that peak point ని vertex అంటారు. నేమ్ ఇచ్చారు vertex అని. దాన్ని కానీ ఒక లైన్ పాస్ అయితే, ఇప్పుడు సర్కిల్ ఉంది అనుకోండి. If I pass a line through center, is it not line of symmetry?
Yes, sir.
Yes, sir.
So is it real or virtual a line? It could be virtual or real. It could be anything. But there is a line of symmetry. All right. So I'm drawing an imaginary line there. All right. Right, as of now, it is imaginary line, but there could be a wall there, or there could be a tower there, or there could be a person standing on this line. All right. There could be a physical wall there. ఇక్కడ wall ఉండొచ్చు, or there could be a mirror also. ఒక question లో mirror ఉంటుంది ఇక్కడ. So this line is line of symmetry. అంటే this part of this curve is as a reflection of this along this line. This part is a reflection of this part along this line. With respect to this line, it's a reflection. అంటే if I fold this one, I'll get this part, or if I fold this one, I'll get this part. All right.
Okay, sir.
Or more technically, if I rotate this axis by 180 degrees, like this, okay, like this, I'll get back the same curve. That's line of symmetry. All right. Now, one point which I want to make very clear is this line of symmetry and G bar are parallel. Always. G bar and line of symmetry are parallel. That point is very important to note. All right. So G bar and this line of symmetry are parallel. So if I have got G effective, G by 6 rastanu. That time also moon మీద ఇసిరేస్తే కూడా I'll have a parabola again, along axis of which will be parallel to G by 6. All right. This point will widen in applications as we go further. But the point is, axis of the parabola, which is line of symmetry of the parabola, is parallel to G bar. It is obvious in this case, but there are cases where it is not obvious. All right. There is a tricky question. Okay, previous mains law, previous MSET law, BITSAT law, ilanti questions వచ్చాయి, which are based on this fact. The fact is that line of symmetry, that is axis of the parabola, is parallel to G bar. It is common sense here, but there are cases where it is not common sense. So there you have to remember that it is parallel to G bar always. G bar downward unte ఈ curve ఇలా ఉంటుంది. For instance, there is a situation where G bar is upward, Gx is upward. So my parabola will be like this. All right. There is a case, let's say, how this case is arised, we'll talk about later. But let's say there is a case such that Gx is this way. Now universe ila undi, such that my earth is here, my Gx is this way. So my parabola will be like this. My parabola's axis is parallel to G bar, is a point which I want to convey right now, which is very common sense, it's very commonsensical now. But there are cases where it is not commonsensical. That time you have to remember that axis of the parabola is parallel to acceleration vector. Acceleration vector kinda unte, my axis of the parabola is vertical parallel to this one, and this cup will be downward. All right. ఇది ఇంకా ఎలా ఆలోచించవచ్చు? Why is it downward curve? Downward ఎందుకు వచ్చింది నాకు? నాకు పారాబోలా చెప్పే ముందే నేను డౌన్వర్డ్ చెప్పగలను. ఎలా చెప్పగలను? ఇది పార్టికల్ ఇక్కడ వెళ్ళి స్టాప్ అయ్యి మళ్ళీ కిందకు వచ్చింది.
Yes, sir.
So intersection of these two is going up and coming down. Intersection of these two is going up and coming down. So I could say there is a downward one. But ఇది సిమెట్రిక్ ఫంక్షన్ లేదా నాకు ఎలా వచ్చింది? ఈ ఈక్వేషన్ తర్వాత వచ్చింది. ఈ ఈక్వేషన్ కోనిక్, it turned out to be a conic. Interestingly, it turned out to be a conic. Which kind of conic? Parabola. Now parabola has a line of symmetry. That line of symmetry is always parallel to G bar is what I'm saying. It is very commonsensical now. Common sense that this is parallel to G bar, దీంట్లో. But there are cases where there is not commonsensical. Right? Okay, now let us talk about this point. V0 ఇక్కడ నుంచి ప్రొజెక్ట్ చేస్తే θ నాట్తో పార్టికల్ ఇలా పైకి వెళ్ళి మళ్ళీ కిందకు వచ్చింది. This, when it comes to the same horizontal level, this is called range of the particle. All right. This height from vertex to this horizontal base is called maximum height of the particle, H max. Maximum height reached by the particle. The time it takes from here to here is called time of flight of the particle. All right. In three cases, three things we have to find out. And the bad news is chemistry class ledu, you have got physics class continued.
Sorry,
All right.
it is not a bad news.
Okay. Okay. No, no. What I'm going to say is there is no chemistry class. We're going to continue with physics class. All right. So you'll have to
Okay.
bear me for some more time. All right. Now let's continue. So these three things is what we have to find out. చూడండి h max ఇంకా x కనుక్కోవాలి ఇంకా t naught కనుక్కోవాలి. These three parameters are the basic parameters of the parabolic path of a projectile. Project చేయగానే basic questions ఇవే వస్తాయి MSET లెవెల్లో. What is the maximum height? What is the range? What is the time of flight? Time of flight is total from here to here. ఇక్కడ నుంచి ఇక్కడ వరకు ఎంత టైం తీసుకున్నది? T0/2. T0/2 is total is T0. సో రేంజ్ ఎంత ఉంటుంది? మాక్సిమం హైట్ ఎంత ఉంటుంది? టైమ్ ఆఫ్ ఫ్లైట్ ఎంత ఉంటుంది? ఇలాంటి క్వశ్చన్స్ వస్తాయి. Now let us find out the range and maximum height. I'll find out range from here. See, what is A naught? A naught is tan theta. What is B naught? G by 2 V naught square cos square theta. All right. ఇది A naught B naught గుర్తు పెట్టుకుందాం. తర్వాత సబ్స్టిట్యూట్ చేద్దాం. బట్ ప్రస్తుతానికి let us think in terms of A naught and B naught. Okay. Look at this. I'll write this y is equal to x times A naught minus B naught x. X కామన్ తీసుకున్నా. Now it is 0 initially. మళ్ళీ 0 ఎప్పుడు అవుతుంది కనుక్కోవాలి నేను. అంటే I'll equate this to 0. If I equate this to 0, it is becoming 0 twice. One when x is equal to 0. The other x is equal to A naught by B naught. Correct?
Can you repeat once again?
Yeah. Sure. చూడండి I've got this equation కదా, x కామన్ తీసుకున్నా.
One
x
second.
కామన్ తీసుకుంటే ఏమొచ్చింది? A naught minus B naught x వచ్చింది. x into A naught minus B naught x. ఎక్స్పాండ్ చేస్తే A naught x minus B naught x square వచ్చింది కదా. x కామన్ తీసుకున్నా అంతే. But now with this y coordinate is becoming 0 again over here. చూడండి it is cutting x axis కదా. It is at origin first, cutting x axis here. It is again cutting x axis ఎక్కడ? ఇక్కడ. After one range of the particle. సో రేంజ్ కనుక్కోవాలంటే నేను ఈ పాయింట్ కనుక్కుంటే నేను నాకు రేంజ్ వచ్చినట్టే కదా.
Yeah,
ఈ
sir.
పాయింట్ ఇది ఆరిజిన్. ఈ పాయింట్ కోఆర్డినేట్ కనుక్కుంటే r0, 0. ఆ కోఆర్డినేట్ ఇస్ నథింగ్ బట్ ద రేంజ్.
Yes, sir.
Okay, everyone, is it okay?
Yes, sir.
All right. Okay, now look at this. See, we are just doing the geometry right now. Kinematics, so we'll enter into kinematics, but we are dealing with the geometry right now. All right, conic section మాట్లాడి parabola derive చేసి. All right, then we are getting the geometric parameters of this trajectory. Now trajectory ఏమొచ్చింది? What is the trajectory of the particle? Which kind of curve it is?
Parabola, sir.
Parabola. Okay, now this point is 0. This point is r0, 0. If I get r0, that is nothing but the range. అది ఎలా కనుక్కుంటాను?
Yes.
My y is becoming 0 again. So y ని equate to 0 చేస్తాను. So y is becoming 0 twice. X is equal to 0 ఉంది. That is when particle is launched. When the particle is coming back and hitting x axis, x is equal to A naught by B naught. Right? Right? Is it okay?
Yes, sir.
Others?
Yes, sir.
Okay. Okay, now let us substitute A naught and B naught. Can you substitute and tell me what is x? X is equal to tan theta by G by 2 V naught square cos square theta.
Yes, sir.
ఇది సింప్లిఫై చేద్దాము. What do you get if I simplify? Let's see. Is equal to sin theta by cos theta
Is
into
equal to
G.
tan theta.
Yes, tan theta. Tan theta ni sin theta by cos theta రాశాను. All right. G కింద ఉంటుంది. 2 V naught square cos square theta పైకి వెళ్తుంది. 2 V naught square cos square theta is in the numerator. ఆల్ రైట్, ఒక కాస్ థీటా క్యాన్సిల్ అయిపోతుంది. నౌ వాట్ డు ఐ గెట్? I'll get 2 V naught square sin theta cos theta by G. But what is 2 sin theta cos theta? I can write this as sin 2 theta
by G.
by G. So my range is nothing but V naught square sin 2 theta by G. All right. If at all motion in a plane is covered in your class, you can recollect that range of the particle is given by V naught square sin 2 theta by G. I have
Yes, sir.
derived it without entering into kinematics yet. Geometry నుంచి derive చేసుకున్నాను. All right. So range of the particle is V naught square sin 2 theta by G. Yes, please.
Last steps R naught
Okay.
is equals to. Last R naught is equals to.
R not equal to. Okay. See, I've got 2 V naught square sin theta cos theta వరకు అర్థమైంది కదా. I had
Yes,
sin
sir.
theta by cos theta tan theta. Cos theta cancel అయింది. ఒక cos theta మిగిలింది. Sin theta into cos theta రాశాను. Sin theta into cos theta. 2 V naught square as it is. G as it is. So 2 V naught square sin theta cos theta. So 2 sin theta cos theta is nothing but sin 2 theta. That's a formula in trigonometry. All right.
Yes, sir.
So I'll get V naught square sin 2 theta by G is my this coordinate. బట్ ఆ కోఆర్డినేట్ ఏంటి? ఇక్కడ నుంచి ఇక్కడ వరకు డిస్టెన్స్ ఇస్ కోఆర్డినేట్. అంటే దట్ పార్టికల్ వెన్ ఇట్ ఇస్ హిట్టింగ్ బ్యాక్ అగైన్ ఎట్ ఎక్స్ యాక్సిస్, మళ్ళీ గ్రౌండ్ కి ఎప్పుడు హిట్ అవుతుంది, ఇక్కడ నుంచి లాంచ్ చేస్తే మళ్ళీ హిట్ అవుతుంది కదా గ్రౌండ్ కి. సో దట్ డిస్టెన్స్ ట్రావర్స్ బై ద పార్టికల్ హారిజాంటల్ డిస్టెన్స్ ఇస్ రేంజ్. దాన్ని టెక్నికల్ టర్మ్ ఇచ్చారు రేంజ్. రైట్. సో రేంజ్ ఆఫ్ ద పార్టికల్ ఇస్ V naught square sin 2 theta by G. All right.
Yes, sir.
Okay.
Okay, sir.
Now let us find out the maximum height.
It's my.
ఇప్పుడు మాక్సిమం హైట్ ఎలా కనుక్కోవచ్చు నేను? ఎనీ ఐడియా? ఫ్రమ్ జియోమెట్రీ, ఇంకా కైనమాటిక్స్ సెంటర్ కాలేదు. ఆల్రైట్. సి దిస్ అప్రోచ్ ఇస్ డిఫరెంట్ ఫ్రమ్ వాట్ ఈస్ టాట్ ఇన్ యూజువలీ. మీరు కంపేర్ చేస్తే మీ క్లాసెస్ లో కైనమాటిక్స్ తో రేంజ్ చేస్తారు కదా, అది కూడా చేస్తాను. బట్ ఐ హావ్ గాట్ దిస్ రేంజ్ ఫ్రమ్ జియోమెట్రీ ఫస్ట్. రైట్.
Yes, sir.
సో నౌ హౌ విల్ యు గెట్ ది మాక్సిమం హైట్? ఈ పాయింట్ ఏంటి? లైన్ ఆఫ్ సిమెట్రీ అన్నాను. సో దిస్ పాయింట్ విల్ బి r/2, 0. రైట్. r0/2, 0 ఉంటుంది కదా ఈ పాయింట్. దిస్ లైన్ ఆఫ్ సిమెట్రీ పాసెస్ త్రూ r0/2 కదా. వై? బికాస్ లైన్ ఆఫ్ సిమెట్రీ ఇస్ దిస్ పాయింట్ కి సెంటర్ లో ఉంటుంది.
Range by 2, yes, sir.
r0/2 ఉంటుంది కదా, రేంజ్ బై 2. రైట్, రేంజ్ బై 2. ఇప్పుడు నేను r0/2 ఈ ఈక్వేషన్ లో పెడితే నాకు ఈ పాయింట్ వస్తుంది కదా. వాట్ ఇస్ ద ఈక్వేషన్ ఆఫ్ దిస్ పాయింట్, కోఆర్డినేట్ ఆఫ్ దిస్ పాయింట్? r0/2, h max. అయితే h max కావాలంటే if I substitute r0/2 in this equation, I'll get
Yes,
h max. Right? Let us quickly substitute and simplify that.
Why could be H max, maximum height?
Yeah, why is h max? So ఎలా రాస్తాను? h max is equal to a0 into r0/2 minus b0 into r0/2 whole square.
Whole square.
So h max is equal to, so a0 r0/2 కామన్ తీసుకుంటే a0 minus b0 into r0/2. ఇప్పుడు r0/2 సబ్స్టిట్యూట్ చేస్తాను. వాట్ ఇస్ r0? v0 square 2 into sin theta cos theta by g. That is r0. r/2 చేస్తే 2 వెళ్ళిపోతుంది. సో దట్ ఇస్ నథింగ్ బట్ v0 square sin theta cos theta by g into tan theta minus b0. What is b0? g by 2 v0 square cos square theta into r by 2. Is it okay? నేనేం చేయలేదు, జస్ట్ సబ్స్టిట్యూట్ చేశాను అంతే. ఏం సబ్స్టిట్యూట్ చేశాను? r0/2 సబ్స్టిట్యూట్ చేశాను. దేంట్లో? ఈ ఈక్వేషన్లో. ఆల్రైట్.
Sir.
Maximum height is reached at what point? At r by 2. If range is r, at r by 2 maximum height is reached. So I substitute r by 2 in this equation, I'll get maximum height. Now ఈ పాయింట్ కావాలనుకో, I want this height, why not? So I'll substitute x0 in this equation, I'll get y0. That's it now. If I substitute this in the function, I'll get the vertical height of the function, the value of the function kada.
Excuse me, sir.
Yes.
Why T0 came, sir?
T0 is the
TT.
time.
Sir, tan theta. Just now you wrote, no, sir,
A
tan
equal
theta
to tan
minus.
theta.
Right, a0 is equal to tan theta. చూడండి, I've taken r by 2 common, a0 minus br by 2, right? So a0 ఏంటి? a0 ఏంటి ఇంతకు ముందు ఈక్వేషన్ లో? a0 is tan theta కదా?
Yes, sir.
y is equal to
Yes, sir, I understood.
tan theta x minus 2v0 square cos square theta x square. This is b, this is a. Sorry, a0, b0. అందుకే a0 ని tan theta రాశాను, b0 ని g by 2v0 square cos square theta రాశాను. ఇప్పుడు చూద్దాము. What I'll do, v0 square gets cancelled out, g gets cancelled out, 1 cos theta gets cancelled out. So I'll have
Cos.
tan theta minus tan theta by 2. Tan theta minus tan theta by 2. Sin theta by cos theta by 2. So tan theta minus tan theta by 2 ఏముంటుంది? Tan theta by 2. I'm going little faster. Alright, ఈ సింప్లిఫికేషన్స్ మనం ఫాస్ట్ చేయాలి. Tan theta minus ఒక cos theta క్యాన్సిల్ అయిపోయింది, g క్యాన్సిల్ అయిపోయింది, v0 స్క్వేర్ క్యాన్సిల్ అయిపోయింది. What is remaining is sin theta by 2 cos theta. Sin theta by cos theta is tan theta. What remains is tan theta by 2. Tan theta minus tan theta by 2 is a minus a by 2 ఎంత ఉంటుంది?
A, sir.
No, a minus
A by 2, sir.
a by 2. So tan theta minus tan theta by 2 ఎంత ఉంటుంది?
Tan theta by 2.
Tan theta by 2. Everyone is okay with that?
Yes, sir.
All right. Now again, I'll write this tan theta as sin theta by cos theta. Sin theta by cos theta. So one cos theta gets cancelled out. What remains is sin theta into sin theta, which is v0 square sin square theta.
Into cos square.
Cos cancel అయిపోయింది.
Yeah, sir.
Sin square theta by 2g.
2g.
All right. See, so this is the maximum height. Now you can compare this with your previous knowledge, if at all you have, about the motion in a plane. All right, చాలా మందికి motion in a plane అయిపోయింది. So you can recollect that this is maximum height formula, v0 square sin square theta by 2g. Hana Gayatri, do you recollect this formula?
Yeah, sir. మా క్లాస్ లో కూడా అయిపోయింది.
ఓకే, మీ క్లాస్ కూడా అయిపోయిందా? బట్ మీ
Yeah,
క్లాస్ త్రూ టైం చేసే ఉంటారు, త్రూ కైనమాటిక్స్ చేసే ఉంటారు, రైట్?
Yes, sir.
Yes,
బట్ వీ హావ్ డన్ త్రూ జియోమెట్రీ ఫస్ట్. మనం కైనమాటిక్స్ లో చేద్దాము, బట్ త్రూ జియోమెట్రీ కూడా చేద్దాం, బికాస్ ఫ్యూ క్వశ్చన్స్ కెన్ బి అటాక్డ్ ఈజీలీ త్రూ జియోమెట్రీ. ఆల్రైట్, that we will see our applications. But now, okay, so this is maximum height. So maximum height occurs at what point? At r by 2. Why? Because line of symmetry is passing through r by 2. And line of symmetry passes through vertex. That vertex coordinate ఏముంటుంది? r by 2, h max. h max వచ్చేసింది నాకు. r వచ్చేసింది, h max వచ్చేసింది. So I got two important parameters of this function. Now, let me just explain what do we mean by range. Technically, what is meant by range? Default meaning ఏంటి? Range ఏంటంటే, I've got a particle moving from here to here. Range is defined when the particle is again coming back to the same level. Alright, దాన్ని range అంటారు. Y-axis is again becoming 0. Sorry, y coordinate is again becoming 0. That horizontal distance covered is range. If I say the particle is projected like this, and it is landing here. This is not called range. This is not called range. This is called range. All right. Range is when the particle is again coming back to the same level. Geometrically, it is the root of the equation. Idoka root, idoka root. Two roots machalo distance is my range. All right. This is called horizontal displacement. But this is called range. So horizontal displacement when the particle is again coming back to the y is equal to 0. Y is equal to 0 నుంచి స్టార్ట్ అయ్యి మళ్ళీ y is equal to 0 వస్తుంది. Now let us say this particle is going and hitting a wall. ఇక్కడ వాల్ ఉంది, వాల్ కి హిట్ చేస్తుంది. సో ఇక్కడ హిట్ చేసి ఇలా వస్తుంది. సో దిస్ ఇస్ నాట్ కాల్డ్ రేంజ్. దిస్ ఇస్ కాల్డ్ రేంజ్. ఆల్రైట్, దిస్ అగైన్ హారిజాంటల్ డిస్ప్లేస్మెంట్. కానీ రేంజ్ దేనికంటారు? వెన్ ది పార్టికల్ ఇస్ గోయింగ్ ఫ్రమ్ హియర్, if there were no wall, it will hit here. So this is the range of the particle. Alright, అర్థమైందా range? What do you mean by range?
Yes, sir.
Alright. So range ఇంకా horizontal displacement చాలా difference ఉంది. Okay, now let us talk of kinematics of this motion. చూడండి, ఇప్పుడు నాకు T0 కావాలి. 3 పారామీటర్స్ ఉన్నాయి అన్నాను, రేంజ్, మాక్సిమం హైట్ అండ్ T0. T0 కావాలంటే ఏం చేస్తాను? This particle, I told you, this particle is holding a horizontal rod, is moving up, stopping and coming down. As stop అయినప్పుడు is time of ascent. మళ్ళీ కిందకు వచ్చినప్పుడు time of descent. So time of ascent is equal to time of descent. ఒక పార్టికల్, now look at this one. ఒక పార్టికల్ V0 తో ప్రొజెక్ట్ చేశాను along this line in space. ఒక లైన్ along this line ప్రొజెక్ట్ చేశాను and retardation is A0. ఇది పైకి వెళ్ళి ఆగి మళ్ళీ కిందకు వస్తుంది కదా.
Yes, sir.
After how much time will it stop? V is equal to V0 minus AT equal to 0. So T is equal to V0 by A0. అంత సేపు తర్వాత ఆగిపోతుంది. But it will again come back after what time? 2T. So my answer is total time of flight will be 2 V0 by A. Is it clear?
No, sir. అర్థం కాదు.
Okay. ఈ along this line particle is going one dimension particle. In one dimension అర్థం చేసుకుంటే 2 dimension చాలా easy. Why? Because 2 1 dimensions superposed to get 1 2 dimension. Alright? Superposition of these two 1 dimensions is 2 dimensional trajectory. Trajectory ఎలా తెచ్చుకున్నాను? Y is equal to x తెచ్చుకున్నాను ఇంతకు ముందు, హాఫ్ అన్ అవర్ ముందు. ఇప్పుడు పారాబోలా తెచ్చుకున్నాను. Like that you will have different trajectories. Superposition of x-axis and motion along x-axis and motion along y-axis is giving me trajectory of the particle. Ultimate motion of the particle. Now, ఇక్కడ along the straight line particle project చేస్తే with the retardation A, downward acceleration A, పైన V0. అయితే after what time will it stop? I equate this to 0. I'll get T is equal to V0 by A. So V0 by A is the time after which it is stopping. మళ్ళీ సేమ్ టైం తీసుకుంటుంది మళ్ళీ ఈ పాయింట్కి రావడానికి. సో ఎంత టైం తీసుకుంటుంది T0 టైమ్ ఆఫ్ ఫ్లైట్ అంటే 2 V0 by A. Is it clear now?
Yes, sir.
సేమ్ థింగ్ ఇక్కడ పార్టికల్ 1 dimension. ఇప్పుడు నేను y axis మాట్లాడితే ఓన్లీ y axis మోషనే మాట్లాడతాను. ఇక్కడ y axis మోషన్ చూస్తే దిస్ పార్టికల్ ఇస్ ప్రొజెక్టెడ్ టు velocity V0 sin theta. Alright, particle projected V0 sin theta under retardation G. ఇది పైకి వెళ్తుంది, ఆగి మళ్ళీ కిందకు వస్తుంది. సో టైమ్ ఆఫ్ ఫ్లైట్ ఎంత ఉండాలి? V0 sin theta G, sorry, theta minus GT equal to 0. So T is equal to V0 sin theta by G. This is the time after which the particle stops. It will again come back to the same point in time 2 V0 sin theta by G. So 2V by A ఉంది, ఇక్కడ A ప్లేస్ లో G ఉంది, V0 ప్లేస్ లో V0 sin theta ఉంది.
So where
This
is
formula-
half 1/2?
ఏది?
అక్కడ 1/2 రాలేదు కదా సార్. V0 sin theta minus 1/2 కదా.
అది ut plus half at square. ఇది v is equal to u plus at.
Okay, sir.
Okay, so v is equal to u plus at, vy is equal to u plus at, u is v sin theta minus gt. దీన్ని ఈక్వల్ టు 0 చేస్తే నాకు టైమ్ ఆఫ్ అసెంట్ వస్తుంది, బట్ ఐ నో టైమ్ ఆఫ్ అసెంట్ ఇస్ ఈక్వల్ టు టైమ్ ఆఫ్ డిసెంట్ ఫ్రమ్ అవర్ వన్ డైమెన్షన్ మోషన్. సో టోటల్ time of flight will be 2 into time of ascent, 2v naught sin theta by g. Now compare these two equations and remember this format. This format is very important in whole of projectile motion. ఈ ఫార్మాట్ గుర్తుంటే we can crack problems in seconds. లేకపోతే ప్రతిసారి మనం డిరైవ్ చేయాల్సి వస్తుంది, బట్ ఈ ఫార్మాట్ గుర్తుంటే you can crack it seconds లో. If a particle is moving with velocity v naught under acceleration a naught, opposite acceleration a naught, its time of flight is 2v naught by a, right? ఇక్కడ ఏముంది, దీంట్లో సిమిలారిటీ ఏముంది, ఏ ప్లేస్ లో g ఉంది, v naught ప్లేస్ లో v naught sin theta ఉంది. So particle is going up, v naught sin theta will stop after v naught sin theta by g, it will come down with v naught sin theta by g, after a time v naught sin theta by g. So total time would be 2 v naught sin theta by g. All right. సో నాకు టైమ్ ఆఫ్ ఫ్లైట్ ఎంత వచ్చింది ఇప్పుడు, టీ నాట్, క్యాపిటల్ టీ నాట్, క్యాపిటల్ టీ నాట్ ఎంత వచ్చింది, 2v naught sin theta by g వచ్చింది. All right, so I got r naught, which is v naught square sin 2 theta naught by g. I got h max, which is
V naught
v naught square
square.
sin square theta by g, 2g, correct, and t naught as 2v naught sin theta by g. I got all the three parameters of a projectile motion. ఒక projectile ని
Yes.
throw చేస్తే it turned out to be a conic. Interestingly, it turned out to be a parabola. Interestingly, it has an axis of symmetry. Even more interesting is axis of symmetry is parallel to g bar, which is very important point. All right, now, okay, fine. So that's it. Now let us look at one point again. Okay, now look at this one point. If I project a particle vertically upwards with v naught, acceleration is downward. I told you we are studying motion of the particle under constant acceleration. Acceleration is g throughout or gx throughout. G by 6 on moon, g on this one, in a car something, in a lift something, but it's constant throughout. Now, if I leave a particle, if I drop a particle, what is the velocity? 0. Acceleration is downward. If I project a particle upward, v naught is upward, g is downward. If I project a particle downward, g is downward, v naught is downward. But if I project a particle like this, v naught is this way, g is this way. Now look at this, students. Let us write this, the generic font for this. ఇలా వదిలేస్తే పార్టికల్ స్ట్రైట్ లైన్ లో వస్తుంది, రైట్?
Yes, sir.
స్టూడెంట్స్,
Yeah, sir.
ఓకే,
Yes, sir.
అదర్స్ పార్టికల్ ఇలా వదిలేస్తే స్ట్రైట్ లైన్ లో వస్తుంది, రైట్? జస్ట్ డ్రాప్ దిస్
Yeah.
పాయింట్, స్ట్రైట్ లైన్ లో వెళ్ళిపోయింది. పార్టికల్ ని ప్రొజెక్ట్ చేస్తే ఇది కూడా స్ట్రైట్ లైన్ పైకి వెళ్ళి మళ్ళీ కిందకు వస్తుంది. పార్టికల్ ని కింద ప్రొజెక్ట్ చేస్తే పార్టికల్ స్ట్రైట్ లైన్ వెళ్తుంది. What is common in all these three? Straight line motion, and that straight line is straight line is parallel to g bar, right? We have to mathematize this fact. Adi chesdamu. Now this is parallel to g bar, right? Straight line is parallel to g bar. ఇలా ప్రొజెక్ట్ చేస్తే ఏమొచ్చింది నాకు, ఇప్పుడు డిరైవ్ చేసాం కదా, ఇలా పారాబోలా వచ్చింది with axis parallel to g bar. That's what we got now. If I
Yes, sir.
project it like this or like this, I'm getting straight lines parallel to g bar. G effective rastano, so that you remember that g bar is on earth, g by 6 on moon, g by something on somewhere else, something in car, something in lift. All right. But throughout this 3 segments of the motion law, first segment law of motion in a plane, 3 segments ఏంటి? Parabola, circle, spiral.
Spiral.
First motion లో ఏం చదువుతున్నాం మనం? Under constant acceleration చదువుతున్నాం. In that, if I drop a particle, this particle is going along straight line. If I project a particle vertical upward, it goes up, comes back in a straight line. This also comes in a straight line with a common property that these straight lines are parallel to gx.
Gx.
Yes, sir.
If I project a particle at an angle, not vertical, but at an angle, it turns out to be a parabola, beautiful conic, with an axis parallel to g bar.
Yes, sir.
Alright, now look at this. I'll mathematize this. చూడండి, ఇక్కడ parallel anti parallel ఉంది. So if I write what is a cross b, a cross b ఏంటి? ab sin theta కదా, right? a cross b,
Yes, sir.
mod a cross b is ab sin theta. So ఇది sin theta ఇక్కడ 0 ఉంది, because ఇక్కడ velocity 0 ఉంది. So this turns out to be 0. This cross product is 0. v naught cross g bar is 0. ఇక్కడ ఏముంది cross product? v naught cross g bar ఏముంది? Sin 180. What is sin 180? 0 again. So v naught cross g bar is again 0 here. ఇక్కడ ఏముంది? v naught cross g bar is again 0 here. 0, 0, 0. ఇక్కడ ఏముంది? It is non-zero. ఈ కేసులో non-zero ఉంది. Alright.
Why, sir?
అందరికి అర్థమైందా ఈ పాయింట్?
సార్ నాకు ఏ నోట్ క్రాస్ బి నోట్ అర్థం కాలేదు.
Cross product of two vectors is defined as ab sin theta into some vector, no, n cap. So magnitude of this cross product is ఏంటి? ab sin theta. Right? Dot product ఏంటి? ab cos theta. Cross product ab sin theta. Okay, vectors లో చదివాము. Alright, you just remember, otherwise if you don't remember vectors, you just remember right now that cross product is given by ab sin theta. Magnitude of the cross product is given by ab sin theta. Alright, ఇప్పుడు sin theta ఇక్కడ ఏంటి? b is 0, ఇక్కడ v naught is 0, sorry a is 0, so sin cross product is 0. ఇక్కడ ab non-zero, but sin theta is 0. Theta is 180, so sin theta is 0. Cross product is 0. ఇక్కడ angle is 0. Theta is 0, so sin theta is 0. ఇక్కడ angle is non-zero, non-180. In that case, my cross product is non-zero. So I'll mathematize this fact that if I leave a particle, or if I project a particle, downward and upward, that is parallel and anti-parallel to g, my motion is straight line. If I project a particle at an angle with g, which is neither parallel nor anti-parallel, then I'll get a parabola. So how do I mathematize it? I'll say if cross product of v naught and g, gx, why am I saying gx? Is equal to 0, path is a straight line. If v naught cross gx is non-zero, it is a parabola with the axis parallel to g bar. Alright, so v naught cross gx equal to 0 వస్తే it's definitely a straight line. Here v naught cross gx is non-zero, it's a parabola.
Yes, sir.
సో ఎప్పుడైనా నాకు gx ఇచ్చేస్తే, ఒక సిచ్యువేషన్ నాకు gx ఇచ్చారనుకోండి, నాకు gx somehow hypothetical situation లో, అది not hypothetical, that is a factual situation, practical situation, but ఇప్పుడు వరకు hypothetical, నాకు gx ఈ డైరెక్షన్ లో ఇచ్చారనుకోండి, alright, instead of vertically downward, it's at this angle. అప్పుడు if I project a particle, if I release a particle, in which direction will it go?
Downward direction.
Along gx bar. That's what, see, if v naught cross gx is 0, it will go along
gx.
parallel to g bar, parallel to gx bar. Agreed? అర్థమైందా ఇది?
Yes, sir.
Yes, sir.
Just remember this is a fact. We'll apply this heavily in some problems. కొన్ని ప్రాబ్లమ్స్, ప్రీవియస్ ఒలింపియాడ్ ప్రాబ్లమ్స్ ఇలా క్రాక్ చేయొచ్చు ఈ ఫ్యాక్ట్ అర్థమైతే. ఈ ఫ్యాక్ట్ ఏంటి? దట్ V naught cross G bar is 0. I think this is a straight line motion with this line parallel to Gx bar.
Yes, sir.
If V naught cross Gx is non-zero, it's a parabolic motion with an axis parallel to Gx bar. So ఒక hypothetical situation లో Gx bar ఇలా ఉంది. Alright, constant acceleration motion. A particle ని ఇలా వదిలేశాను. So that will be around Gx bar. So particle will come straight like this. But if I project a particle like this, in this part, in this one, in this Gx, under this scenario, particle ఎలా వెళ్ళాలి? Will it go straight up and down? No. It will be a parabola
Parabola.
with the axis parallel to Gx bar. So particle will be like this. Particle will go like this. It will not go vertically up and come down. Because it's in this hypothetical scenario, my acceleration is this way. This cross product, if you remember, you can crack problems even in second year. Electrostatics law, magnetostatics law, ఎక్కడైనా motion, parabolic motion వస్తే, this fact will help you crack problems quickly. What is the fact? If the cross product of V naught and Gx bar is 0, the motion is straight line with a line parallel to Gx bar. Alright. If V naught bar and Gx bar is non-zero, what value I'm not bothered. I'm just bothered about whether it's 0 or non-zero. 0 on a straight line with a line parallel to Gx bar.
Gx bar.
If it is non-zero, it is parabola with the axis parallel to Gx bar.
Yes, sir.
It will be curved towards Gx bar. Curved open towards Gx bar. ఇక్కడ చూడండి, curved open towards Gx bar.
Yes, sir.
Alright. Take a snapshot of this. Alright, this is a very important fact. And you will not find this in books.
So is it V naught bar means velocity?
Yes, it's velocity. Oh, I didn't
Okay.
mention it. It's velocity. V naught bar is velocity. G is acceleration. Constant acceleration. And this cross product fact is only valid for constant acceleration. Alright, if the acceleration is variable, then this parabola fact is not valid. It is turning out to be parabola only when we had a constant acceleration. Derive చేసేటప్పుడు నేను constant G తీసుకున్నాను. Right? So this turned out to be a conic only because G is constant. And that too, it turned out to be a parabola.
Yes, sir.
Alright. Now, okay.
Sir,
Okay. Yeah.
can I ask one thing?
Sorry.
మొన్న మీరు చెప్పారు ఈరోజు క్వశ్చన్ పేపర్ డిస్కస్ చేద్దాం.
Yeah. But thing is, I thought I'll continue with this. Rape చేసుకుందాం. Question paper rape discuss చేసుకుందాం.
Okay.
Alright. Let us go deeper into this one. అందరు రాసారా పేపర్?
Yes, sir.
Yes, sir.
We have got new student also today.
నేను రాయాలి సార్
ఎవరు రాయలేదు?
క్వశ్చన్ పేపర్ రాది
ఎవరు పేరేంటి?
కుమార్ నవనీత్ కుమార్
ఓకే అదే న్యూ స్టూడెంటా?
ఎస్ సార్
ఓకే అయితే రాయగలుగుతారా ఈరోజు? కానీ
ఓకే
మీకు చూడండి, మీకు సిలబస్ కాలేజ్లో ఏం నడుస్తుంది ఇప్పుడు?
కాలేజీలో క్లాసెస్ ఈ రోజు ప్రోగ్రామ్ ఉంది సార్
కాలేజ్లో ఏం నడుస్తుంది ఇప్పుడు? ఈ వాట్ ఈస్ గోయింగ్ ఆన్ దీస్ డేస్? ఈ మధ్య ఏం నడుస్తుంది? ఏ టాపిక్ నడుస్తుంది ఫిజిక్స్ లో?
ఫిజిక్స్ లో ఫస్ట్
వెక్టర్స్ అయిపోయిందా?
కాలేదు సార్
ఓకే, ఇంకా వెక్టర్స్ కూడా కాలేదా?
కాలే
ఓకే ఏ కాలేజ్ మీరు?
మోడల్ స్కూల్ నన్నూర్
నర్నూర్ మోడల్ స్కూలా? ఓకే now let us go little bit into our functions and let us see something interesting. చూడండి, I've got a particle like this, projected a particle like this with at an angle 30 degrees, let's say. Okay, or let's say theta only. theta. Under G. So whenever you see a particle projected under constant acceleration, first see whether its cross product is 0 or non-zero. Is the cross product 0 or non-zero? Cross product between V naught bar and G bar. Is it 0 or non-zero?
Non-zero, sir.
Others?
Non-zero, sir.
Non-zero. So what kind of path will it take?
Parabola.
All right, parabola. So will it be
Yes, sir.
this
Parabola.
parabola? This parabola?
No, sir.
That's what
Yeah.
you should mention it completely. Parabola with the axis parallel to
GX bar.
X.
Gx bar. And that means it will be open towards G bar.
B
So it will
bar.
be this parabola.
Yes, sir.
All right. Think in terms of these times. Till you get this consolidated in your mind, we cross product fact consolidate every time you see a constant acceleration in a vector, velocity vector ఇంకో constant acceleration vector చూస్తే just quickly see cross product 0 non-zero. Non-zero అంటే parabola ఉంటుంది, ఇలా ఉంటుంది. 0 అంటే straight line ఉంటుంది. Definitely straight line along with straight line parallel to G bar. All right. ఇప్పుడు ఇలా పార్టికల్ ఇలా వెళ్ళింది. రైట్. ఒకవేళ ఇఫ్ ఐ కీప్ చూడండి మన ఒకవేళ ఇది గ్రౌండ్ అనుకోండి, ఒక పార్టికల్ ఇలా హిట్ అయింది V naught తో, రీబౌండ్ అవుతుంది V naught తో ఇఫ్ దర్ ఇస్ నో లాస్ ఆఫ్ ఎనర్జీ. రైట్.
Yes, sir.
అండ్ దిస్ యాంగిల్ విల్ బి ఈక్వల్ టు దిస్ యాంగిల్ ఇఫ్ దర్ ఇస్ నో ఫ్రిక్షన్.
Yes, sir.
Yes.
How can I say this? I can say from optics also. Law of reflection. Angle of incidence is equal to angle of reflection. Right?
Reflection.
Yes.
Same follows for particle also. It is class 10th కూడా ఒకసారి చూసాం ఇది. Angle of incidence is equal to angle of reflection. So angle with which the particle is striking is equal to angle with which at which particle is rebounding.
Reflection.
Fine. అదే పార్టికల్ ఇలా హిట్ చేస్తే ఎగ్జాక్ట్లీ వర్టికల్లీ డౌన్వర్డ్ హిట్ చేస్తే పార్టికల్ ఎలా రీబౌన్స్ అవుతుంది? ఇలా వెళ్తుందా?
Straight number.
స్ట్రైట్ వెనక్కి వెళ్ళిపోతుంది. స్ట్రైట్ వెనక్కి వెళ్ళిపోతుంది. రైట్.
Straight number.
So if I keep a wall here, exactly where at r by 2, r naught by 2, r naught ఇది r naught by 2 ఇది origin. Exactly at r naught by 2 wall పెడితే ఏమవుతుంది? This particle the trajectory. See, if I want to know the direction of velocity, ఒక trajectory ఉంది. If I just want to know the direction of velocity, how will I do? I'll draw a tangent to it. And that is the direction in which the particle is moving. Right? సో నాకు ఇక్కడ డైరెక్షన్ కావాలంటే ఏం చేస్తాను? ఇలా టాంజెంట్ డ్రా చేస్తాను. ఇక్కడ డైరెక్షన్ కావాలంటే ఏం చేస్తాను? ఇలా టాంజెంట్ డ్రా చేస్తాను. ఇక్కడ కావాలంటే ఏం చేస్తాను? ఇలా టాంజెంట్ డ్రా చేస్తాను. ఇక్కడ కావాలంటే ఏం చేస్తాను? ఇలా టాంజెంట్ డ్రా చేస్తాను. సో టాంజెంట్ ఇస్ హారిజాంటల్ ఎట్ ద వర్టెక్స్. యు అగ్రీ?
Yes, sir.
At the highest point, my tangent is horizontal. We'll talk about kinematics later. Okay, there's a hell lot of things to talk about in this one. First geometrical తీసుకొని మళ్ళీ kinematics వెళ్తాం మనం. All right. So it is hitting this wall perpendicularly. Do you agree with that? Wall is vertical, velocity is horizontal, so it is hitting the wall perpendicularly. You all agree with that?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now, if it hits perpendicularly, it will rebound perpendicularly. చూడండి ఇక్కడ. If a particle hits a wall perpendicularly, it will rebound perpendicularly. Fine. Fine.
Yes, sir.
So if it rebounds perpendicularly, it will follow the same path.
Yes, sir.
It will come back to this. So if a person is throwing on the wall, if it hits the wall perpendicularly, it will come back to his own hand.
Again, it is building.
మళ్ళీ చేతికి వచ్చేస్తుంది. Provided there is no loss of energy. If there is loss of energy, things are different. All right. And that is not there in the syllabus. What happens if it is at an angle, అవన్నీ ఉన్నాయి. But what happens if there is, okay, the syllabus and all we'll talk later. But right now you understand that if it hits perpendicularly, it will rebound perpendicularly. If it's rebound perpendicularly, it will follow the same path and it will come back to his own hand. So this path and this path is going to same. But so where will it land? It will land again at origin, right?
Yes, sir.
Yes, sir.
But now let us say the wall is somewhere here. ఇక్కడ r by 2 దగ్గర లేకుండా it is a 3r by 2, let's say. All right, it is a 3r/2. Now it is hitting like this, it will rebound like this, such that this angle is equal to this angle. Agree?
Yes, sir.
Agreed? Okay. Now, because it's hitting at this angle, this part and this part will be same. I mean symmetric. Symmetric ఉంటుంది. Alright? ఉంటుందా లేదా?
Yes, sir.
The question is, where will it land? After hitting the wall, which is at a distance of x naught from origin, where will the particle land? CNT. Alright? That's the question. ఎలా చేస్తాము? Do you understand the geometry of this one?
Yes, sir.
Yes, sir.
ఓకే, పార్టికల్ ఇలా వెళ్ళింది, ఇలా హిట్ అయింది, ఇలా కిందకు వచ్చింది. సో ఇట్ ఈస్ హిట్టింగ్ సమ్వేర్ హియర్. నౌ దిస్ ఇస్ సిమెట్రిక్ టు దిస్ వన్, ఆబ్వియస్లీ కదా, బికాస్ దిస్ వెలాసిటీ ఇస్ సేమ్.
Yes,
I
sir.
mean, speed is same, velocity is not same. Velocity is symmetric, so motion will also be symmetric further. Further motion is symmetric because these velocities are symmetric. ఈ velocity symmetric ఉన్నాయి. చూడండి, ఒక పార్టికల్ ని ఇలా వదిలేస్తే, ఒక పార్టికల్ ని ఇలా వదిలేస్తే, ఇది పారాబోలా ఇలా వెళ్తే, ఈ పారాబోలా ఇలా వెళ్తుంది. దీస్ విల్ బి సిమెట్రిక్ కదా. If these velocities are symmetric with respect to vertical, this parabola will also be symmetric with respect to vertical.
Mm.
Yes, sir.
Ante kada. So this is going to be symmetric. This is x naught. Now this is d. Sorry, this is x naught. Identa untundi r naught minus x naught.
X naught.
Now కావాల్సింది x. So ఇదేంటి, ఇప్పుడు x ఎంత వస్తుంది? This is also r naught minus x. ఇప్పుడు కావాల్సింది ఏంటి? x naught minus r naught minus x. X is equal to x naught minus r naught minus x, which is equal to 2x naught minus r naught. So I get x as 2x naught minus r naught. అర్థమైందా ఇది?
Yes, sir.
I'll give you an interesting homework in stop.
Sir, can you repeat it again?
Yes, sure. And what's your name? Who is it?
Gayatri, sir.
Okay, Gayatri. Yeah, sure, Gayatri. Okay, now see, I'm just measuring the distances along the horizontal. Okay, geometry line is okay, line no, I'm just measuring the distances and summing up the distances or subtracting the distances. This is symmetric to this one. If these two are symmetric, this distance is equal to this distance, right? ఈ
Yes.
డిస్టెన్స్ ఏమో x naught, ఈ డిస్టెన్స్ ఏమో x naught. ఈ డిస్టెన్స్ ఎంత ఉంటుంది? టోటల్ డిస్టెన్స్ r naught. R naught minus x naught is this one.
Yes, sir.
So this is also r naught minus x naught.
Sir.
ఇది r naught minus x naught. X ఎంత ఉంటుంది? Total is x naught. X naught minus r naught minus x naught is x.
Yes, sir, I understood.
So 2x naught minus r naught. Report, if I ask you what should be x naught such that it should come back to an own hand, come back to the origin, అంటే ఏం చేస్తాను? X should be equal to 0. X should be 0 now. If the particle is supposed to come back to this origin, ఈ పాయింట్ 0 అయిపోవాలి కదా.
Yes, sir.
So x naught ఏమొస్తుంది? X naught is equal to r naught by 2. That's what we got initially. Now wall r naught by 2 దగ్గర ఉంటే it's coming back to its origin కదా. That's what we got. ఇంతకు ముందు just only r naught analysis చేసాము r naught by 2 ఉన్న చోట. But now I'm doing it for general thing. General wall. ఎక్కడైనా wall ఉంటే r naught by 2 2x naught minus r naught దగ్గర వస్తుంది. But if I want that to come back to x is equal to 0, I'll equate this to 0. I'll get x naught is equal to r naught by 2. Alright?
Yes, sir.
Now, what if I keep a wall here? ఎక్కడ వెళ్తుంది పార్టికల్? ఏమవుతుంది పార్టికల్ కి?
బ్యాక్వర్డ్ వెళ్తుంది సార్, మనం వేసిన.
రైట్, ఇలా వస్తుంది పార్టికల్. వై? వెలాసిటీ is hitting like this, it will rebound like this, this velocity and this velocity are symmetrical. ఈ సిమెట్రికల్ అంటే ఈ పార్టికల్ ఇలా వెళ్ళిందంటే ఈ పార్టికల్ ఇలా రావాలి కదా.
Yes, sir.
Yes, sir.
I have to find out this one, x. ఈ x ఎలా కనుక్కుంటాను? I'll just substitute x naught is equal to this one. Let's say this is 3 r by 4. r by 4 substitute చేస్తా ఇక్కడ. So what will I get x as?
2 r naught by 2.
2 r naught by 2 minus r naught.
Okay, minus.
అప్పుడు ఏమొస్తుంది ఫైనల్ ఆన్సర్?
Minus or not?
Minus r naught by 2.
Yeah, sir. Minus r by 2, not by 2.
అంతే కదా. If this is minus r naught by 2, now tell me where is the vertex of the parabola? ఇది r naught by 2 అంటే vertex ఎక్కడ ఉండాలి? చూడండి ఇలా, ఇది r naught by 2 అంటే నా రేంజ్ ఇక్కడ వరకు ఉంటుంది కదా. This will pass through this one. This obviously pass through this one కదా. Why? Because this is r by 4, this is r by 4. r by 4 అంటే it should pass through this one. If this is r by 2, this is r by 2. So my vertex has to be at origin. Agreed?
Yes, sir.
Everyone?
Yes, sir.
Divya, better unmute and speak, no? Because Divya, are you there? Divya, if you just text it like this, I may miss it. All right. So if you unmute and speak, I'll get to know that where you are missing. All right. So I don't know which equation you're talking about. So I think you're talking about this equation. Are you talking about this equation?
Yes, sir.
All right. So we still have 10 minutes, 10, 12 minutes. I can explain this again and I'll give you homework, interesting homework.
Sir,
Yeah.
the distance between, the position and the stone was stopped is r0 minus x.
ఏంటి మళ్ళీ చెప్పు సారీ.
ఇప్పుడు మన పొజిషన్ నుంచి ఒక స్టోన్ వేసాం కదా సార్.
అవును, ఆరిజిన్ నుంచి వేసాను.
అక్కడ బ్యాక్వర్డ్ వెళ్ళాక ఒక ప్లేస్ లో ఆగిపోయింది కదా.
ఇలా వెళ్ళి పార్టికల్ ఇలా హిట్ అయ్యి ఇలా వెనుక వచ్చి
బ్యాక్వర్డ్
ఇలా ఇక్కడ అంటున్నారా?
ఈ డిస్టెన్స్ ని మనం r0 by x అని రాసుకోవచ్చా?
r0 by x
minus x సారీ సార్.
ఓకే ఒక్క నిమిషం. I'll just quickly derive this. ఇది x naught. I'll quickly derive it again so that things are again clear for everyone. And my wall is somewhere here. Wall is here.
Yes, sir.
If this rebounds with same angle, all right, no loss of energy and following principle of reflection, this velocity and this velocity are symmetric. So this comes like this. If this is and this is symmetric, this will be equal to this. And this total is r naught. This is r naught comma 0, right? This is x naught comma 0. This is x naught. కావాల్సింది x. Now look at this, Divya. This is how much? This is equal to this, right? And how much is this? R naught minus x naught. And so how much will this be? R naught minus x naught. If this is R naught minus x naught, this total is x naught. What is x? X minus R naught minus x naught. See, total is x naught. కావాల్సింది x. This is R naught minus x naught. Total is x naught. This is R naught minus x naught. కావాల్సింది x. X naught minus of x is equal to x naught minus of R naught minus x naught, which is equal to 2x naught minus R naught. So this x I got it as 2x minus r naught. Okay, that's how I got the equation. Equation ala vachindi. Now, what I did, I placed a ball over here at r by 4. Right? Now, this particle will hit like this and go behind. Now you are asking something, Vignesh. What is it you are asking?
So distance between the position and the stone.
Either.
Yes, sir.
This is what I have to find out. So x naught I'll substitute as r by 4. 2 into r by 4 minus r naught, which is equal to minus r naught by. That's very small. I'll write it again. Sorry. 2 into r naught by 4 minus r naught, which is minus r naught by 2. So negative. This origin kada negative. Minus r naught by 2 vastundi. So minus r naught by 2. Don't remember this formula. You can see you will have so many equations in 2 years. మనం గుర్తు చేసుకోలేము. But remember the logic. ఇది ఎలా తెచ్చుకున్నాను. Alright. So if you don't have a question, go with the logic again. Don't go with this plugging into r 2x naught minus r naught. Alright, don't do this. అదే let's do it over here itself. ఇది నాకు తెలీదు, ఇది ఈక్వేషన్ నాకు తెలీదు, కానీ ఇలా ఇచ్చారు సిచ్యువేషన్. ఇప్పుడు తెలుసుకుందాము. This is x naught. This total is r naught. So this is r naught minus x naught.
Yes, sir.
Right. So this is equal. So this is r naught minus x naught. So this is also r naught minus x naught. So r naught minus x naught is equal to. ఇక్కడ ఏముందండి? This is ball is over here at x naught. This is r naught. And okay, this is r naught minus x naught. Sorry. So this is equal to x naught. X naught is equal to r by 4. So r naught minus r by 4 is equal to r by 4. So x is equal to r naught minus r by 4. Just length అనుకుంటున్నాను. Oh, something wrong. X naught, r naught, x naught, r naught. Oh, sorry. Look at this. X plus x naught plus this one is r naught. So r naught minus of x plus x naught is equal to x naught. Right? So I'll have x is equal to r naught minus 2x naught. చూడండి ఈక్వేషన్ ఇప్పుడు రివర్స్ వస్తుంది. Alright, so I'm just talking about distances అందుకే ఇలా వచ్చింది. I'll substitute x naught is equal to r by 4, which is equal to r naught minus 2 into r by 4, which is equal to r by 2. So x naught is x is equal to r by 2 వచ్చింది, but the coordinate will be minus r by 2 because it's left of origin. నాకు length x r by 2 వచ్చింది. Understand this point?
Yes, sir.
The coordinate is negative r by 2. No, r naught by 2, but length is r naught by 2. That's I found out the length by measuring distances over here by symmetry and everything. But I got x as r naught by 2, but coordinate will be minus r naught by 2 because it's left of origin. All right.
Yes, sir.
Okay. Now the question is homework is we still have 5 minutes. I can tell you the homework. Studying homework is little interesting. But to understand to do the homework, you will have to understand transformation of graph. F of x plus a, f of x minus a. Hint కూడా ఇచ్చేసాను. Alright, ఇలా నాకు గ్రౌండ్ ఉంది, ఇది ఆరిజిన్, ఇది r naught. I have got a wall over here. Alright, ఇది ఇలా రిఫ్లెక్ట్ అయింది. ఇలా రిఫ్లెక్ట్ అయింది, right? This part will be symmetric to this part. Alright. Now look at this. This is symmetric to this one, right? ఓకే, నౌ ది క్వశ్చన్ ఇస్, దీని ఈక్వేషన్ ఏమొచ్చింది నాకు? v0 sin theta tan theta ax minus b0 x square అని ఈక్వేషన్ వచ్చింది, రైట్? a0 b0 ఏదో ఉంది. వాట్ ఇస్ a0 tan theta? b0 is g by 2 square cos square theta, 2 v0 square cos square
Sir,
theta. Sorry?
Can you write big, sir?
Yeah, sorry. I've got a very bad habit. Is it okay now?
Yes, sir.
Okay, I'm sorry. All right. Now look at this. I've got the equation of this curve. Curve A and curve 1 అనుకుందాం. Or curve 1. ఇది curve 2. Now, ఇది different function కదా, ఇదైతే same function. So curve 1 ది equation ఇది ఉంది,
Yes, sir.
right? I want the equation of curve 2. Okay, I want ఇది r/2 అంటే r/2 దగ్గర ఉంటే ఏముంటుంది వాల్? వాట్ ఇస్ ది ఈక్వేషన్ ఆఫ్ కర్వ్ 2? సేమ్ థింగ్,
Then how?
సేమ్ ఉంటుంది. పార్టికల్ ఆపోజిట్ వస్తుంది, బట్ ద ట్రాజెక్టరీ సేమ్ కదా, సో ఈక్వేషన్ ఇస్ సేమ్.
Yes, sir.
But it is not at r/2, it is at some, let's say 3r/4. Sorry, 3r/4 దగ్గర హిట్ అయ్యి వెనుక వచ్చి మళ్ళీ ముంగట వెళ్తుంది కదా, సో ఇట్ విల్ హిట్ సమ్వేర్ హియర్. ఎక్కడ హిట్ అవుతుందో కనుక్కోండి. రైట్, ఆల్ దీస్ థింగ్స్ యూ హావ్ జస్ట్ నౌ డన్, యూ కెన్ డూ దట్. ఎక్స్ కనుక్కోవచ్చు అవన్నీ. బట్ నౌ ఐ హావ్ టు ఫైండ్ అవుట్ ద ఈక్వేషన్ ఆఫ్ దిస్ కర్వ్. అంటే ఏ కర్వ్, దీన్ని ఎక్స్టెండ్ చేస్తే ఇలా వస్తుంది, అలానే వస్తుంది కదా దాన్ని ఎక్స్టెండ్ చేస్తే. అలానే వస్తుంది కదా దాన్ని ఎక్స్టెండ్ చేస్తే.
Yes, sir.
Yes, sir.
ఈక్వేషన్ ఆఫ్ 1 ఇస్ a0 x minus b0 x square. a0 b0 ఏమో tan theta v0 cos theta అవన్నీ ఉన్నాయి. బట్ ఈక్వేషన్ ఆఫ్ 2 కావాలి నాకు. ఎలా కనుక్కుంటాను ఈక్వేషన్ ఆఫ్ 2 ఇస్ అ క్వశ్చన్.
X is equals to
నాకు ఇది ఈక్వేషన్ ఇచ్చారు, f of x ఇచ్చారు, ఐ వాంట్ g of x. రైట్, f of x ఇచ్చారు, ఐ విల్ సే ఇట్ ఇస్ f of x and this is g of x. f of x ఇచ్చారు, I want g of x, and let's say this is d అనుకుందాము, or a d naught. Where it is sitting, I call it d naught.
Parallel to lines g of x.
G of x is,
Parallel to lines, line symmetric.
yeah, this is symmetric, exactly. This line is symmetry is parallel to g bar. That's what you're saying.
Yes, sir.
That is right. But one more thing you have to notice is this parabola and this parabola are exactly in structure they are same. Frame same ఉంది రెండింటిది. ఈ పారాబోలాని ఇలా పెట్టేస్తే ఆ పారాబోలా వచ్చేస్తుంది, రైట్?
Yes, sir.
Find the equation of g of x. Got it?
Okay, sir.
Think about it and do the 10 minutes exercise. All right, because it has 2 hours, do it 15 minutes exercise. Do all that we have done now. All right, cross product factor is very important. All right, cross product is 0, particle goes in a straight line with a line parallel to g bar. Cross product is non-zero, particle goes in a parabola with the axis parallel to
gx bar.
gx bar, right?
बातें करें जी करके
Sorry,
ఇక్కడ సెకండ్ పారాబోలా ఉంది కదా,
అవును.
ఇక్కడ మిడ్ పాయింట్ r0/2 ఉంటుంది కదా సార్.
ఇది r0/2 ఉంటుందా? d0?
యా సార్.
షూర్.
ఈ పారాబోలాలో ఇక్కడ మధ్యలో r0/2 ఉంటుంది కదా సార్.
అవును, ఈ పారాబోలాలో r0/2 ఉంటుంది. ఇది
ఇట్లా సార్, దిస్ వన్ సెకండ్ వన్.
సెకండ్ వన్, ఓకే.
అంటే ఇక్కడున్న ఈ ఉంది కదా సార్, ఈ పారాబోలా ఐ మీన్ g of x నుంచి స్టార్ట్ అయ్యి r0 నుంచి స్టార్ట్ అయ్యి ఇక్కడ దాకా ఉంది కదా.
ఇక్కడ పాయింట్స్ రాస్తాను. ఇది పాయింట్ A, పాయింట్ B,
సార్
పాయింట్ D.
బి నుంచి సి వరకు ఎంత డిస్టెన్స్ అయితే ఉంటుందో అదే డిస్టెన్స్ డి నుంచి సి వరకు ఉంటది కదా.
ఇది
I mean,
నేను జనరల్ 3r/4 ఉంటే ఉండొచ్చు. బట్ ఐఎమ్ గివింగ్ యూ జనరల్ పాయింట్ x0 అనుకుందాం. వాల్ ఇస్ అట్ x0, 0. రైట్.
నేను ఏమంటున్నానంటే ఇక్కడ ఈ పారాబోలా ఇది ఈ డిస్టెన్స్ తో టైటన్ అయితే ఇక్కడ కూడా డిస్టెన్స్ సేమ్ ఉండాలి కలిసి మొత్తం. ఐ మీన్ ఇట్ బికమ్స్ పారాబోలా, ఇట్లా వస్తుంది కదా పారాబోలా. అప్పుడు దీని మధ్యలో సిమెట్రిక్ గా తీస్తే రెండు మనము ఆ సిమెట్రిక్ గా తీస్తే బీసీ ఉంది కదా సార్.
అవును, బీసీ ఉంది.
ఆ బీసీ ఈక్వల్ టు సిడి అవుతుంది కదా.
ఓకే,
ఎట్లా
అలా
అవుతుంది?
అనుకుంటున్నారా? ఓకే, ఐ జస్ట్ ప్రూవ్ యూ రాంగ్. ఆ డయాగ్రామ్ అలా డ్రా చేస్తే అలా అనిపిస్తుంది. ఐ జస్ట్ ప్రూవ్ యూ రాంగ్. డయాగ్రామ్ అలా కొంచెం మిస్లీడింగ్ ఉంది. ఐ జస్ట్ డ్రా డయాగ్రామ్ అగైన్. వాల్ ఇక్కడ పెడతాను. ఏ బి సి సారీ సి
డి.
డి. చూడు, ఏబి బీసీ ఇస్ నాట్ ఈక్వల్ టు సిడి. ఓకే,
Yeah, sir.
but line of thought is correct. Think along those lines only.
సార్ నేను ఐ మీన్ ఆ లైన్స్ పాయింట్స్ లో చెప్పలేను, నేను డిఫరెంట్ గా థింక్ చేస్తా అది.
ఓకే, నాకు
ఇక్కడ
అర్థమైంది. యు ఆర్ థింకింగ్ ఇన్ టర్మ్స్ ఆఫ్ రిఫ్లెక్షన్ కదా.
రిఫ్లెక్షన్ అని కాదు సార్. ఇప్పుడు ఈ బీడి పారాబోలా ఉంది కదా సార్.
బీడి పారాబోలా. బీడి పారాబోలా.
దాన్ని హాఫ్ చేయండి సార్. దాన్ని ఒకవేళ హాఫ్ చేయండి.
ఓకే,
హాఫ్ చేస్తే ఇప్పుడు ఈ పాయింట్ కి డి అని ఈ అని పెట్టుకోండి సార్ ఇక్కడ.
ఓకే పెడతాను.
బిఈ ఈక్వల్ టు డిఈ అవుతుంది కదా.
బిఈ ఈక్వల్ టు ఈడి.
ఓకే, ఇప్పుడు ఏబి ఉంది, ఈ ఏబి పారాబోలా ఉంది సార్. ఏసీ
అవును.
సారీ ఏసీ ఏసీ
ఏసీ పారాబోలా. ఓకే,
దీనికి మిడ్ పాయింట్ తీయండి.
ఓకే ఎఫ్ పెడతాను.
ఇప్పుడు ఇక్కడ ఈ ఎఫ్ ఎక్కడ ఇది 1 minute సార్.
సిడి.
ఇక్కడున్న ఎఫ్సి అండ్ ఇక్కడున్న ఈబి రెండు సిమెట్రిక్ కాదా సార్.
ఎఫ్సి ఇంకా ఈడీనా?
ఎఫ్సి అండ్ బిఈ.
ఎఫ్సి ఇంకా బిఈ సేమ్, కరెక్ట్. ఏఎఫ్ ఇస్ ఈక్వల్
అప్పుడు
టు బిఈ, ఎఫ్సి ఇస్ ఈక్వల్ టు ఈడి. సో దట్స్ వై బిఈ ఇస్ ఈక్వల్ టు ఎఫ్సి.
అప్పుడు
See,
మనకి
all these
దీని
things are AF is equal to FC is equal to BE is equal to ED.
దాని ఈక్వేషన్ దీని ఈక్వేషన్ సేమ్ అవ్వచ్చు కదా సార్. ఐ థాట్
చూడు, I've got one equation of line y is equal to x. Okay,
Sure.
ఇది y is equal to ఏముంటుంది? ఇది x 0 పాస్ అయితే ఇది 2 నుంచి పాస్ అవుతుంది. సో ఈ ఈక్వేషన్ ఏముంటుంది? x minus 2 కదా. Or let's say this 2x. So it will be 2 into x minus 2 కదా.
ఎస్ సార్.
సో ఈక్వేషన్ సేమ్ ఉందా?
నో సార్.
స్ట్రక్చర్ సేమ్ ఉంది.
యా సార్.
ఫ్రేమ్ సేమ్ ఉంది. లైక్ ఇఫ్ ఐ జస్ట్ హోల్డ్ ఇట్ లైక్ దిస్, ఐ కెన్ జస్ట్ మూవ్ ఇట్ టువర్డ్స్ రైట్. అలానే ఇది కూడా హోల్డ్ చేసి ఇలా మూవ్ చేసే రైట్ కి నాకు సేమ్ పారాబోలా వచ్చేస్తుంది. బట్ ఈక్వేషన్ ఇస్ డెఫినెట్లీ డిఫరెంట్ బికాస్ ఇట్స్ పాసింగ్ త్రూ డిఫరెంట్ పాయింట్స్.
ఓకే సార్.
ఇట్స్ డిఫరెంట్ ఫంక్షన్ ఆల్ టుగెదర్, బట్ స్ట్రక్చర్ సేమ్ ఉంది. దట్ మీన్స్ వన్ ఇస్ అ ట్రాన్స్లేషన్ ఆఫ్ ది అదర్.
ఎస్ సార్.
ఆల్ యూ హావ్ టు డూ ఇస్ ట్రాన్స్లేట్. ఎంత ట్రాన్స్లేట్ చేస్తారో చూడండి. ఆల్రైట్,
ఓకే సార్.
ఎవ్రీవన్ అండర్స్టూడ్?
Yes, sir.
All right. So shall we stop here? All right, it's already time 7:05.
7-4 वगैरह से.
Okay, 7:04. All right. Sorry, 1 minute less. All right. Okay, so shall we stop? Any doubts so far?
నో
No,
సార్.
sir.
No, sir.
All right. Please do the 10 minutes exercise. It may take 15 minutes today, but do the 15 minutes exercise. Em chestaru, you'll think through everything whatever we have done. We have done except ఒక్కసారి టైం కనుక్కోవడానికి కైనమాటిక్ ఈక్వేషన్ యూస్ చేసాము. దాని తప్ప we were doing whole of geometry only. నిన్న కోనిక్ సెక్షన్స్ మాట్లాడాము, ఆ కోనిక్ సెక్షన్స్ ఇప్పుడు అప్లై చేసాము. Alright? That interestingly turned out to be conic, that turned out to be a parabola, downward parabola. That cross product says that it is parabola with axial symmetry parallel to G bar. Alright, ఇవన్నీ ఫ్యాక్ట్స్ మీరు థింక్ త్రూ చేయండి. అండ్ ద హోంవర్క్ ఇస్, ఈ పారాబోలా ఉంది f of x, I have to get g of x. I also gave you the hint that g of x is nothing but the translation of f of x. But ఎంత ట్రాన్స్లేట్ చేయాలి is what you have to find out. Alright? Okay. Oh, Divya, you missed yesterday's class. Then, okay, if you miss yesterday's class, you will not understand that it's a parabola. Or except that fact, you will understand everything. The parabola derivation అర్థం కాకపోవచ్చు, but everything you will understand except that the part that the derivation is a parabola. All right, Divya. Okay, but if at all you have got doubts, you can ask me tomorrow, Divya. All right, then see you tomorrow or see you in the evening. Have a nice day. Have a great day, everyone. Bye, everyone.
Thank you, sir.
Most
Thank you,
welcome.
sir.
Bye, everyone.
Thank you, sir.
Bye, sir.
Bye, bye. Thank you, ma'am.
ఈ మిత్రులు
Punika.
Excuse me, ma'am. Chandrika, ma'am. Yeah, students, you can leave the room. Yeah. Bye, everyone.